Go.
Hello, we are
Team
Team
6838, System Overload.
I'm Noah. I am an 8th grader. I'm also a mechanical engineer and in charge of the engineering notebook. I have 2 years of experience.
I'm Joel. I'm the social engineer. I have 1 year of experience. I'm in 6th grade.
I am Jack. I am the software engineer. I'm in 8th grade and I have 2 years of experience.
I'm Zaid. I'm in 7th grade. I'm a CAD designer and I have 1 year experience.
I am Mitchell. I am in 7th grade. I am the mechanical engineer and I have 1 year of experience.
I am Seth. I am in 8th grade. I have 2 years of experience. I'm a mechanical engineer. This video is for the Create US Open Robotics VEX Middle School Division Championship.
Yes, you got to be ready. Go ahead and call it out.
Wait, no.
I read this off.
Mitchell, then Zaid, then Jack.
Okay. The first part about our
The question
Rob-
is Mitchell.
What is the most
Oh.
difficult task in building your
the
robot?
most difficult part of building our robot was calibrating the accuracy of our shooter.
Okay, point to it.
The core strength of our robot is its versatility and it is very accurate and can shoot for multiple areas.
One of the improvements we could make is speed. We could clear the field faster and incorporate a ramp or lift system.
We've done multiple things to help spread VEX awareness, such as participating in our hometown homecoming parade, and also going to Barnes & Noble, and also helping out elementary schools and showing off our robots to them.
So with our flywheel, we have a 35-to-1 gear ratio, allowing us for a perfect speed, for a perfect combination of speed and torque. And with our catapult, it is done with faster preload time, also allowing us to have a faster reload speed due to the slip gear.
The first part about our feeder is the elevator. The elevator lifts the balls up to the flywheel shooter. The second part is the feeder. This brings the balls into the elevator. Lastly is the bailing system. This pulls the balls in, allowing the rubber bands to flex with the balls. At first, we had a wheel design, but this was putting too much pressure on the balls. We have mecanum wheels, so we can move side to side, diagonally, and forward and backwards.
My work was to build an initial design concept using CAD. I built a visual model of the base, feeder, and the flywheel shooter.
Our program speeds up the flywheel design and displays the speed on the LED screen. The one battery is allocated to just the flywheel. The other battery is allocated to everything else. That's all.
When we were first starting at robotics and began brainstorming ideas, we decided to prototype a flywheel launcher, similar to how ours is currently, but with different concepts in mind. We only had 1 wheel originally, and we had a different gear ratio with a different setup. Our base was also a lot smaller than it is now. It was 13 by 13 inches rather than the almost 18 by 18 maxed out that we have. we began innovating afterwards, and we got to similar steps that were more like how we have it now. But instead of that, it was. And innovating was something that we constantly were doing throughout our build process. We had a loader design, and as you can see, it was vertical now, but originally it was a diagonal. And we also had a tilt system that would show the angle. However, that was simply took up too much space, and the tilt would make our shot really varied depending on where we had it. So we eliminated that, and we also worked on a different flywheel setup, which saved space and also gave us more power and speed. A more recent development would be the bottom feeder that was also part with the rubber bands instead of the wheels in the front that was described earlier, as well as our catapult shooter, which has the shaved gears that allow you to release pressure on when the rubber bands are pulled back, allowing you to launch forward, which was made simply so that we could shoot faster instead of having to wait the 4 seconds that our flywheel would take to get back to speed.
6.
My job was to help design the board, and so here we have some skills of the other team during competitions to help us see where we match up with them. In most of them we have green, so that means we have a higher advantage of them. And then over here we have a heat chart telling like their average wins, their average losses, and their rank. The red means they're in the bottom 1/3 grouping for that category. The middle means the yellow means they're the middle 1/3 grouping for that category. And then the green means they're the top 1/3 grouping for that category. On our list we have quite a lot of greens.
7.
Thank you for taking time to watch our video, and we can't wait to meet with you in Nationals competition.